you can do again. All you need is a plan. Plan your time. Make sure you start now, because the sooner you start, the better chance you will be able to cover everything in your syllabus and even more content than you have already done. Pay more attention on the subjects which you know that you may be experiencing challenges with. Know your strengths and weaknesses. This will help you to know what you should prioritize. Reflect on your performance throughout the year. Seek help. Asking for help is a very good thing. We cannot all be good at everything. If we have a friend and you know they are good at specific subject, schedule study time with a friend and help each other. Use every possible source of help to improve your weak points. If you are good at something, help your fellow learners and exchange ideas. Your educators can also help. You have libraries, you have your parents and your community, but also you have what other grade 12s in the country don't have at this moment. And this is the Internet Broadcast Project, the IBP. Use this platform, it is very helpful. Here are some tips to help you prepare better in order for you to gain a sustained competitive advantage. 1, start now. The sooner you start, the better. 2, allocate enough time in a day to study. This means spend less time having fun, but having fun with your studies. 3, use previous test and exam papers. This will help you anticipate what to expect in the exam. 4, form study groups. Make friends with people who can help you and people you can also help. 5, make sure you take breaks between your studies. If your brain is tired, a power nap can help revitalize your concentration. 6, a good diet and drinking enough water will keep you refreshed and energized. 7, take advantage of the days leading to the exams by making sure you pay more attention in class. 8, find a quiet place to study. During the day in most of our community there is loud noise, especially at home, but libraries can help you with a quiet place, and also your schools. 9, make sure you have enough sleep, because sleep helps restore energy and concentration. And finally, approach your studies as a fun exercise, because if you enjoy what you do, it becomes a fun thing to do. These are some of the 10 tips to help you prepare better and achieve your goals for the coming exams. Go out there prepared and bring those distinctions. Make us proud. Work as a team, because it is my considered view that individual brilliance can only win us games, but teamwork will always bring us championships. Let me greet you all and convey my gratitude at being able to bring you the grade 12s of the Free State this message. The time has come for you to get ready for your final examination at the end of this year. I know this is a daunting task that you are faced with, but let me assure you that with good preparation, determination and discipline, you can get through it with hard work, focus and determination. Grade 12 is your last year of high school and a step towards your future careers. And with that said, you have to make sure you approach your final exams with a goal in mind. Let me tell you that you can do this like your peers have done before you. In 2016 and 2017, the Free State was the top performing province in grade 12, and this you can do again. All you need is a plan. Plan your time. Make sure you start now, because the sooner you start, the better chance you will be able to cover everything in your syllabus and even more content than you have already done. Pay more attention on the subjects which you know that you may be experiencing challenges with. Know your strengths and weaknesses. This will help you to know what you should prioritize. Reflect on your performance throughout the year. Seek help. Asking for help is a very good thing. We cannot all be good at everything. If we have a friend and you know they are good at specific subject, schedule study time with a friend and help each other. Use every possible source of help to improve your weak points. If you are good at something, help your fellow learners and exchange ideas. Your educators can also help. You have libraries, you have your parents and your community, but also you have what other grade 12s in the country don't have at this moment. And this is the Internet Broadcast Project, the IBP. Use this platform, it is very helpful. Here are some tips to help you prepare better in order for you to gain a sustained competitive advantage. 1. Start now. The sooner you start, the better. 2. Allocate enough time in a day to study. This means spend less time having fun, but having fun with your studies. 3. Use previous tests and exam papers. This will help you anticipate what to expect in the exam. 4. Form study groups. Make friends with people who can help you and people you can also help. 5. Make sure you take breaks between your studies. If your brain is tired, a power nap can help revitalize your concentration. 6. A good diet and drinking enough water will keep you refreshed and energized. 7. Take advantage of the days leading to the exams by making sure you pay more attention in class. 8. Find a quiet place to study. During the day, in most of our community, there is loud noise, especially at home, but libraries can help you with a quiet place, and also your schools. 9. Make sure you have enough sleep, because sleep helps restore energy and concentration. And finally, approach your studies as a fun exercise, because if you enjoy what you do, it becomes a fun thing to do. These are some of the 10 tips to help you prepare better and achieve your goals for the coming exams. Go out there prepared and bring those distinctions. Make us proud. Work as a team, because it is my considered view that individual brilliance can only win us games, but teamwork will always bring us championships. Let me greet you all and convey my gratitude at being able to bring you the grade 12s of the Free State this message. The time has come for you to get ready for your final examination at the end of this year. I know this is a daunting task that you are faced with, but let me assure you that with good preparation, determination and discipline, you can get through it with hard work, focus and determination. Grade 12 is your last year of high school and a step towards your future careers. And with that said, you have to make sure you approach your final exams with a goal in mind. Let me tell you that you can do this like your peers have done before you. In 2016 and 2017, the Free State was the top performing province in grade 12, and this you can do again. All you need is a plan. Plan your time. Make sure you start now, because the sooner you start, the better chance you will be able to cover everything in your syllabus and even more content than you have already done. Pay more attention on the subjects which you know that you may be experiencing challenges with. Know your strengths and weaknesses. This will help you to know what you should prioritize. Reflect on your performance throughout the year. Seek help. Asking for help is a very good thing. We cannot all be good at everything. If we have a friend and you know they are good at specific subject, schedule study time with a friend and help each other. Use every possible source of help to improve your weak points. If you are good at something, help your fellow learners and exchange ideas. Your educators can also help. You have libraries, you have your parents and your community, but also you have what other grade 12s in the country don't have at this moment. And this is the Internet Broadcast Project, the IBP. Use this platform, it is very helpful. Here are some tips to help you prepare better in order for you to gain a sustained competitive advantage. 1. Start now. The sooner you start, the better. 2. Allocate enough time in a day to study. This means spend less time having fun, but having fun with your studies. 3. Use previous tests and exam papers. This will help you anticipate what to expect in the exam. 4. Form study groups. Make friends with people who can help you and people you can also help. 5. Make sure you take breaks between your studies. If your brain is tired, a power nap can help revitalize your concentration. 6. A good diet and drinking enough water will keep you refreshed and energized. 7. Take advantage of the days leading to the exams by making sure you pay more attention in class. 8. Find a quiet place to study. During the day, in most of our community, there is loud noise, especially at home, but libraries can help you with a quiet place, and also your schools. 9. Make sure you have enough sleep, because sleep helps restore energy and concentration. And finally, approach your studies as a fun exercise, because if you enjoy what you do, it becomes a fun thing to do. These are some of the 10 tips to help you prepare better and achieve your goals for the coming exams. Go out there prepared and bring those distinctions. Make us proud. Work as a team, because it is my considered view that individual brilliance can only win us games, but teamwork will always bring us championships. Let me greet you all and convey my gratitude at being able to bring you the grade 12s of the Free State this message. The time has come for you to get ready for your final examination at the end of this year. I know this is a daunting task that you are faced with, but let me assure you that with good preparation, determination and discipline, you can get through it with hard work, focus and determination. Grade 12 is your last year of high school and a step towards your future careers. And with that said, you have to make sure you approach your final exams with a goal in mind. Let me tell you that you can do this like your peers have done before you. In 2016 and 2017, the Free State was the top performing province in grade 12, and this you can do again. All you need is a plan. Plan your time. Make sure you start now, because the sooner you start, the better chance you will be able to cover everything in your syllabus and even more content than you have already done. Pay more attention on the subjects which you know that you may be experiencing challenges with. Know your strengths and weaknesses. This will help you to know what you should prioritize. Reflect on your performance throughout the year. Seek help. Asking for help is a very good thing. We cannot all be good at everything. If we have a friend and you know they are good at specific subject, schedule study time with a friend and help each other. Use every possible source of help to improve your weak points. If you are good at something, help your fellow learners and exchange ideas. Your educators can also help. You have libraries, you have your parents and your community, but also you have what other grade 12s in the country don't have at this moment. And this is the Internet Broadcast Project, the IBP. Use this platform, it is very helpful. Here are some tips to help you prepare better in order for you to gain a sustained competitive advantage. 1. Start now. The sooner you start, the better. 2. Allocate enough time in a day to study. This means spend less time having fun, but having fun with your studies. 3. Use previous tests and exam papers. This will help you anticipate what to expect in the exam. 4. Form study groups. Make friends with people who can help you and people you can also help. 5. Make sure you take breaks between your studies. If your brain is tired, a power nap can help revitalize your concentration. 6. A good diet and drinking enough water will keep you refreshed and energized. 7. Take advantage of the days leading to the exams by making sure you pay more attention in class. 8. Find a quiet place to study. During the day, in most of our community, there is loud noise, especially at home, but libraries can help you with a quiet place, and also your schools. 9. Make sure you have enough sleep, because sleep helps restore energy and concentration. And finally, approach your studies as a fun exercise, because if you enjoy what you do, it becomes a fun thing to do. These are some of the 10 tips to help you prepare better and achieve your goals for the coming exams. Go out there prepared and bring those distinctions. Make us proud. Work as a team, because it is my considered view that individual brilliance can only win us games, but teamwork will always bring us championships. Let me greet you all and convey my gratitude at being able to bring you the grade 12s of the Free State this message. The time has come for you to get ready for your final examination at the end of this year. I know this is a daunting task that you are faced with, but let me assure you that with good preparation, determination and discipline, you can get through it with hard work, focus and determination. Grade 12 is your last year of high school and a step towards your future careers. And with that said, you have to make sure you approach your final exams with a goal in mind. Let me tell you that you can do this like your peers have done before you. In 2016 and 2017, the Free State was the top performing province in grade 12, and this you can do again. All you need is a plan. Plan your time. Make sure you start now, because the sooner you start, the better chance you will be able to cover everything in your syllabus and even more content than you have already done. Pay more attention on the subjects which you know that you may be experiencing challenges with. Know your strengths and weaknesses. This will help you to know what you should prioritize.
Good morning, teachers. Welcome to this discussion on paper 1 for the grade 12 learners that was written on Friday. And I hope that your learners has experienced the paper as fair and of appropriate standard. And let us now start with the discussion. I will at first start off with two erratas on the paper. First one is on the memo, and the second one is on the paper itself. And on the memo, you will see that it is on question 1.5, and I will really describe this as an errata because the answer is obviously 1.5C. So sorry for that. We have put it on our Matthew cluster group, so I hope that this message will be distributed to the other districts also. And then on the Afrikaans paper, there is a value that differs from the English question paper, and that is in question 5, where the value of the speed of the police car is given as 10.6 and not as 16 as in the English version of the paper. I will rectify the values also when we come to the discussion of the memo on question 5. So then, just to summarize, in question 1, the only correction then is 1.5C. I don't think that there's any other queries about that. So I'll immediately go on discussing question 2. Right. Question 2 then, like always, is a typical question on Newton's laws, and the question stated that there are two blocks, P and Q, resting on a rough horizontal surface, and then they are connected by light string, and the angle at which the force F is acting on the block P is at 30 degrees, and then you will later on see that the values of the frictional forces are also given as respectively 2 and 1 Newton. Right. The first, the next important, very important piece of information is the information on the movement of the two blocks. That is, the blocks are moving at a constant speed of 3 meters per second. So it's highlighted, and therefore it is written in caps. Now 2.1 state Newton's first law of motion in words, and you have the exam guidelines. So I think by this stage all learners make use of the exam guidelines for definitions. So it is part marking on the definition, and the first mark is for the first part that states it will remain in the state of rest or motion at constant velocity. So for both those two statements, rest or motion at constant velocity, 1 tick. And then unless, important that word, in Afrikaans tensy, unless a non-zero resultant or a non-zero net force acts on it, so that is the second mark. So part marking means that if there is some kind of a mistake, a word omitted in the first part, you will lose the mark on the first part. But if the second part is totally correct, you can still get 1 out of 2. But very important, it must be in the context of Newton's law. It must be in the same context. If the first part or the second part has totally referred to any other law, maybe Newton's second law, then immediately this definition isn't within the context, and then the learner will lose all his marks, although maybe the first part or the second part could be correct. But if the first part isn't in context with Newton's first law, for instance, mention maybe something like conservation of energy, etc., but it isn't within the context of Newton's first law, then it is 0 out of 2, although it is part marking. So it's part marking within the context. Right. So that is the definition, and then moving on to the obvious next question, to draw a labeled free body diagram for block P. At this stage is a very like I said, obvious question, and normally the learners perform quite well in this type of questions, and you will see that it is worth 5 marks because there is 5 forces acting on block P. So the total marks must also give an indication to the learners about the number of forces acting on a block. The mark allocation won't be 5 marks if there's only 4 forces. Now you will always see there's acceptable labels given in a table, and the obvious labels is F. Let me use this pen. Right, is F for the force, Fg, normal force, frictional force, tension. So like it's given here on the first option. But then you will see there's a range of acceptable labels, and you will always see that there is labels that is a description of the force applied for weight, gravitational force, normal force, friction, tension, etc. So if the learner is unsure about a label, maybe there's the symbol for the correct label, he can use the description of the force also. So there are the acceptable labels, so take that into account, and remember, if a value is given for a force, you can also use the value of the force also as a correct label. Right, just a few notes. The principle is that there's 1 mark for the direction, the arrow, and the label. That's the principle. The lengths are not taken into account. We don't ask them to draw it to scale, so the length doesn't matter, although you can really teach your learners to also maybe take that into account for technical purposes. And then thirdly, any additional force. If maybe a 6th force was given here, it will be seen as an additional force, so then you deduct 1 mark, so then you can only get 4 out of 5 maximum if all the other forces was correctly drawn and labeled. And then all the forces must make contact with the dot, so to show that it acts on the object. And then lastly, not maybe given on the notes, just the principle also applied that we deduct only once for omission of arrows. Therefore, say for instance the learner omit the arrow for the force FG and the force F, then you will only deduct 1 mark for the omission of an arrow. You don't deduct a mark every time. It's a repeated mistake. Although the first label or note is both arrow and label, we give the benefit to the learner if he have correct labels but omits more than 1 arrowhead, you only deduct once for a omission of an arrowhead. So take into account the notes, then you will see here's an acceptable version. It's not totally the correct one, the preferred one, but if the learner, instead of the applied force F, indicates the 2 components of the force, then you can also give full marks. But you must really emphasize to your learners that a free body or a force diagram is actually the actual forces and not the components of the forces. So really it is accepted, but it is in fact not quite totally correct, but we accept that. Right, then moving on to question 2.3. I'm just going to refer back to the question. 2.3 asked to calculate the magnitude of the force F, but now the values of the frictional forces on P and Q are given as 2,5 and 1 respectively. Right, now calculate the force F. Certainly you must make use of the force equations for both blocks, and then solve this force F by means of simultaneous equations. So therefore, firstly, you write an equation for the forces acting in the direction of motion for block Q, and you will realize block Q has only a frictional force acting backwards and the tension acting to the right. So therefore it is 1 mark for indicating that you apply Newton's second law. You can see here is the versions that is also acceptable. Then 1 mark for substituting the values of the 2 forces acting on Q, tension, and then minus the frictional force because it's in opposite direction, equals to, and very important now, because it's moving at a constant velocity, the learner must know that the acceleration is 0, so that ma is equal to 0. So for indicating 0, there's 1 tick specifically on indicating the 0. You must have a look at the way the learner present it. So maybe he doesn't present it precisely in this way, but for indicating ma 0, and then 1 tick for the left hand side, t minus 1. No mark on the answer for t equals 1. Then you write the equation for the forces acting in the horizontal direction of motion on block P. There's a horizontal component of the force F. There's a tension force pulling the block backwards, and there's a frictional force pulling the block also backwards to the left. Now, no marks again for the formula for Newton's second law. Only formulas now for substitutions, and you will see that the way the marks are distributed, sometimes it's very difficult to really have a fair distribution of marks. But anyway, we have decided that one tick for indicating the horizontal component of the force F, and then 1 mark for substituting the tension, the value for the tension force, and that is derived from the top, and minus the frictional force, and again equals to 0. So 1 mark for this underlined part. Remember, positive marking within a question. If this answer maybe was not T1, but for instance T equals 2 newtons, then you will give a mark if he has substituted minus 2 there. 1 mark for that statement, but then you will lose the mark on the answer. So that is positive marking within the question. Right, so 1 mark for the formula for Newton's second law. For Q, 2 marks for substitutions. For P, 2 marks for substitutions, and 1 mark for the answer to get to 6 marks. If the learner has used the method that is not acceptable, you see that's a problem. Instead of 0, we really discourage learners to use the system approach. We at the end give benefit to the system approach because it is not all wrong. So it's 1 mark for the formula, 1 mark for the whole statement, for the correct substitutions of all the values. The horizontal component, the frictional force on block Q, the frictional force on block P, and MA equals to 0. And for the answer, so 1, 2, 3 marks. So if everything is totally correct, the learner can get only 3 out of 6. That is to penalize him for making use of the system's approach that is not totally correct, because you ignore the tension force acting on the system. Right, then moving on to the next question. The string connecting P and Q suddenly breaks while force F is still applied. So now this rope breaks. What now? Is the direction of the acceleration of block Q now towards the left or right? So this string breaks. What will happen to block Q? Now on block Q, the only force acting on block Q now is the frictional force. Okay? So therefore, the direction of the acceleration will be in the direction of the frictional force. So the acceleration will be to the left. Looking at the memo. So 1 mark, the acceleration is to the left, and the explanation, the only force acting on the object, and the only force is the net force. The only force acting on the object is the frictional force, and that frictional force is to the left. So therefore the acceleration is to the left. 1 mark for to the left, 1 mark for explaining, because the only force acting on the block is now the frictional force, and the learner doesn't need to say and the frictional force acts to the left. Then the last question now is, how will the net force acting on block P be affected? Now the net force on P, now you will clearly see that the tension pulling on block P as well as a frictional force of 1 Newton is not acting on the block anymore. So certainly the net force on P will increase due to these 2 forces, the frictional force and the tension not acting of block Q, not acting on block P anymore. So the simple answer is the net force will increase. Right, getting to the next question. Question 3, and like always, that is predictable. that this question will be on projectile motion, vertical projectile motion, and free fall. It's a very, very simple scenario used. A ball of mass 0.5 kilograms is dropped onto a hard floor 1.5 meters above the ground, and then it rebounds vertically up to a height of 1.4 meters. Ignore the effects of friction. Here the ball is considered as a projectile. Explain the term projectile. Right. Very important is the word object now. It is an object, and projectile is an object upon which the only force acting is the force of gravity. So it's an object on which the only force acting is the force of gravity. Part marking. First part, underline part 1 mark, indicating that that only force is the force of gravity. So the crucial words is the object on which the only force is the force of gravity. So part marking, again, it must be within the context, but if the learner maybe omits one of the words, maybe referring, it is when the only force acting is the force of gravity, it is still within the context. So I will give him, he not clearly indicate maybe the word object, but he refers to the only force of gravity. Then I'll give him 1 mark for this part, not for the first part, because there's a crucial word that is omitted, but it is still in the context. Also accept an object that falls freely, and then he must mention with an acceleration of 9.8 meters per second square, or an object that is launched or thrown or projected with initial velocity and important under the influence of the force of gravity. So an object that is launched under the force of gravity. So this is the acceptable ways of explaining or defining what is meant by a projectile. Okay, I hope you understand the principle of part marking within the context, that you apply that correctly. Right. Next question. Calculate the speed of the ball when it makes contact with the floor after it had been dropped. So initial velocity is 0, height 1.5, g equals to 9.8. So the obvious formula for solving that is option 1 with the formula v final square equals v initial square plus 2a delta y. Right. The marks awarded are as follows. 1 mark for the correct formula. You will see then 1 mark for the complete statement. Very important, all the correct substitutions, and then 1 mark for the answer. The principle of zeros is the following. If you actually have a completely correct equation and the learner omits the 0, we are not going to be harsh to penalize him for that. So although it is actually important for me that, and you must teach your learners that they must show the zeros, I will give the benefit to the learner. Maybe in this case, if this equation was totally correct, that we can still award that mark. So 3 marks for that learner. Then option 2 and 3. Now the learner takes the hard route. He don't choose the obvious equation. He decided for 3 marks he must make use of 2 equations. And firstly, calculates the time taken to reach the ground. So you use this formula, where the time is included in the formula, so he calculates the time as 0.5533. There's no marks on this part to calculate delta T because it's not necessary to do that. So now he can use this time in the following two equations. So the first mark then is on the two final equations that leads to a final answer. And then the mark allocation is the same, one for the formula, one for the complete correct substitutions, all the substitutions must be correct, and then one for the final answer. Again, the principle of positive marking within the question, say for instance this was calculated wrongly, and he transfer this value to the next step, you can give a mark for the correct equation, and then for this substitution step you will forfeit the mark on the answer. So that is positive marking within the question, but at least he must show that he has attempted to calculate delta T, but you can give him a benefit for a mark for the substitution step if that value is not totally correct. But again, he forfeit the mark for the answer. Then also the learner could have done it by means of conservation of mechanical energy. The total mechanical energy at the top is potential energy plus zero kinetic, and at the bottom it is zero potential plus kinetic energy. Substitute the values and it equals V final equals 5.42 meters per second. Again, the same principle, one for the correct formula or statement, one mark for all the correct substitutions, and one mark for the final answer. You will see it may be very harsh, because if he make one substitution error in here, he will forfeit the mark on the second step, and he will forfeit the mark on the answer. That line drawn here it's not supposed to be there, so this is only V final squared. That is a fourth option, and then there's also a fifth option by making use of the work energy theorem. The only force, the net force acting, is the force of gravity. So 1 over 1.5 meters, the force of gravity acts on the object, and then the change of kinetic energy at the top, the velocity is 0, and then you must calculate the velocity at the bottom. So 1 mark again for the formula, 1 mark for the complete correct substitution step, and 1 mark for the final answer. Right, that is the 5 options that the learner can use. Unfortunately, in questions about calculations of velocity, etc., in this projectile motion, you always have a lot of options. I think you have seen in previous final exam memos, it's really sometimes a few pages. Then the next question is now, write down the magnitude and direction of the acceleration of the ball while moving upwards after it has bounced from the floor. When moving upwards, the gravitational force and therefore the acceleration is still downwards, and the value stays at 9.8. So therefore 9.8 is the value of acceleration, but it is still downwards although the ball is bouncing upwards. The next question is the collision with the floor elastic or inelastic? It is certainly inelastic, and therefore the next question leads the learner, actually question 3.5, give an indication that it must be inelastic, because the next question states calculate the change in the kinetic energy of the ball due to the collision with the floor. 2 ways of doing it. Right, you have the final velocity you have calculated in 3.2. So important, it is positive marking from 3.2. So this value of 5.42, you must remember it's positive marking from the previous question. Then the learner must now calculate the initial velocity with which the ball bounces from the floor. So therefore, the final velocity after the ball has bounced is 0, and therefore you can calculate the initial velocity. The height is 1.4 meters, the height of the bounce. So therefore, you can calculate the initial velocity of the ball. That must be I. Sorry for that mistake. That must be I. The initial velocity is then 5.236. And then the learner can calculate the change in kinetic energy. So it is half times 0.5, and then the final velocity minus the initial velocity squared, both squared, you get a value of 0.485. Actually minus 0.49 will be the correct one. Remember, the learner can write more than 2 decimals, but if he writes 2 decimals, it must be correctly rounded. So 0 minus 0.49. In option 2, the learner realizes that the change in the potential energy of the gravitational potential energy of the ball is equal to the lost or the change in the kinetic energy of the ball. So therefore, the potential energy changes because the final height is 1.4 and the initial height is 1.5. So the change in kinetic energy, the loss in kinetic energy, of potential energy is 0.49, and therefore it is equal to the kinetic energy that the ball has lost due to the inelastic collision. Right, so this is the 2 ways of solving the problem. Right, the mark allocation, you will see 2 marks for the first part in option 1, 1 mark for a formula, 1 mark for substitution. The third mark is also for correct substitutions of these values. Again, positive marking within the question. If that value, there was a calculation error in the first part, you can give him a mark for the substitution step if everything else is correct, but then you forfeit the mark on the answer. So 1 mark for a formula, 2 marks for substitutions, and 1 mark for a final answer. It must stay the same in the second option, 1 mark for a statement or a formula, and in this instance, again 2 marks for substitutions, because in option 1 there is 2 marks on substitutions. Therefore, here must be 2 marks on substitutions. So we have given it to the substitution of the 0.5 times 9.8, and the next one for the calculating the difference in height, and then 1 mark for the final answer of minus 0.49. The next question is a question on the graph showing the movement of the ball. Draw a velocity time graph. For the motion of the ball from the moment that it is dropped till it reaches the maximum height of 1.4 after it has bounced. On the graph, indicate the velocity with which the ball makes contact with the floor. Right. If you choose upwards as positive, the learner must start at 0. Very important. Must start at 0. And then it must be a straight line, because it's a velocity time graph. The acceleration is constant, so constant gradient, which end off at minus 4,542 meters per second. And remember, it's also positive marking from the previous questions. You must look at the value calculated in 3.2. So one tick starting at 0, constant gradient, ends off at minus 5,42, one tick. The second tick indicating that there is a time lapse due to the time with which a ball is in contact with the floor. And then the third mark is for a constant gradient, but parallel, very important, parallel to the first line, to the first graph line. So if the learner has chosen downwards as positive, therefore upwards as negative, let me just move down, sorry, right. So if the learner has chosen upwards as negative, downwards as positive, so downwards it has a positive gradient, positive 5,42, so one tick for correct graph, a straight line for the first part, 0, 5,42, gradient, constant gradient. Second mark indicating the time that the ball is in contact with the floor, and the third mark again for a line with a constant gradient but parallel to the first line, because the acceleration must stays the same. And that is what the criteria state here. So you can read through the criteria, and that is how I have explained to interpret this marking criteria for the graph. 15 marks, 3 marks for the graph, and then 15 marks for question 3. Moving on to question 4. And question 4 is on work energy, and a question that is maybe more difficult, a question where we have made an assumption, and I know the assumption isn't actually what is really happening at contact. I know that it isn't certainly an inelastic collision, but to make the problem more easy for the learners, we have indicated this condition, no loss of mechanical energy. So I know you can argue about that, but that is the condition stated in the problem, so the learners must make use of that condition. Ignore friction, and there is no loss of mechanical energy in the whole process. It's a ball of 5 kilograms that is suspended from a string, and it's released from rest at the point 0,67 meters above the ground. Its lowest point is at B, and then when it swings through point B, it collides with a stationary block of mass 2 kilogram. And then immediately after collision, this block moves to the right on a frictionless track BC. Right, on a frictionless track BC. And then the ball swings through up till the height of D. Right. So this is on formation indicated on the graph also. Now the first question explains what is meant by isolated system. According also to the exam guidelines, a system on which the net external force that is acting on an object is 0, or it can be a condition where no external forces is acting on the system. So the net external force acting on the object is 0. 2 marks. Actually, there is no part marking on this. it is 2 or 0. So this is an example of 2 or 0 for this definition. The next question, calculate the velocity of the steel ball immediately after collision. It's worth 7 marks, so certainly it must be a multi-step calculation. For the first part, the first calculation must be to calculate the speed with which the steel ball arrives at point B, and therefore conservation of mechanical energy must be used for that. And then the second part, taking into account the collision, the conservation of momentum during the collision, and that is the way that the learner must solve it. So let us look at the different options. The first option is now where the learner calculates by means of the conservation of mechanical energy the velocity of the ball at point B. Maybe you can write VB here. You will see in the calculation we have omitted the masses because the masses is right through the same. We have omitted the masses. Most of the learners, I will think, will include the mass of 5 kgs. So maybe just have a look out for that the learner will include the 5 kgs. Right, anyway, it is then for the first part calculating the velocity by means of the conservation of mechanical energy, 1 mark for the statement for indicating the conservation of mechanical energy, and then 1 mark for the left hand side, the substitution of the left hand side, and 1 mark for the substitutions on the right hand side. And remember about the zeros, what I've told you about the zeros. If the first statement is complete and totally correct, the zeros can be omitted, but again encourage your learners to substitute the zeros. Right, 3 marks for the first part. No answer on V at B, the velocity at B, but then the learner must use it in the second part of the calculation. You will see firstly 1 mark for stating the principle of conservation of momentum. 1 mark. Second mark for the substitution of the mass times the velocity of B, of the steel ball at B, and 1 mark for the substitution of the values on the right hand side after collision. So it's 5 times the unknown velocity of the steel ball plus the mass of the block times the velocity of the block. So therefore the velocity of the steel ball after collision is therefore 1,6438. Certainly the learner can round it off only to 1,64 meters per second. Okay, so also acceptable, 2 decimals. The second option only differs in the first part, the way that the learner calculates the velocity of the steel ball when it reaches point B. This learner has made use of the conservation, the work done by non-conservative force. There's no non-conservative force, so it is 0, and substitute the delta U and delta K values, and you get the answer. The third, and then use this answer again to get to the second part, solving, making use of the principle of conservation of momentum. 3 marks for the first part, 3 marks for the second part, the same as in option 1. 1 mark for the formula, 1 mark for substitutions, 2 marks for substitutions, like in the first option, and no mark for the final answer. The third option, the learner have made use of the work energy theorem's formula. Same principle, 1 mark for stating that theorem, and then 1 mark for the left-hand side for the net work done by the gravitational force, and 1 mark for the right-hand side, calculating delta K. No mark again for the answer. So 3 marks for the first part. Then he uses that answer in the second calculation. Positive marking within a question again. He can get a mark for this left-hand side, although this can be a wrong value. But again, he will forfeit the mark on the final answer. Right. I know the memo is a bit cluttered, but I hope that you will sort out the ticks. Maybe isn't exactly on the spot that you want to have it, but anyway, I think you will make sense of it. Right. Then moving on to question 4.3. 4.3 then ask, calculate the maximum height h, where at point D, maximum height at point D, and now the learner must make use of actually the principle of conservation of mechanical energy again, stating that the total mechanical energy at the top is equal to, or before, is equal to the total mechanical energy after collision. So before collision, it is only the steel ball that have mechanical energy. After, it is the steel ball as well as the block that makes up the total mechanical energy, final mechanical energy. So therefore, looking at option 1, so it's a principle of conservation of mechanical energy. 1 mark for stating that principle again, and then 1 mark for the mechanical energy before, and that is only the steel ball, and then after, in the final after collision, the block of 2 kilograms have a certain kinetic energy, and the ball have a certain potential energy, and h is the value that you must calculate. This is equal before is equal to after, so the height is calculated as 0.1699 meters. Again, we just state here, do not penalize for zeros if the formula is totally correct. We are just emphasizing that principle. Right, the second option, the learner make use of the fact that the change in the potential energy of the steel ball is actually equal to the gain in the kinetic energy of the block. It's stated in this option that is only accepted the loss of the potential energy of the ball, because the ball doesn't reach the same height. That is the gain of the kinetic energy of the block. So it's, in other words, the steel ball is losing potential energy and the block is gaining kinetic energy. So minus, therefore the minus. So minus, and then 5 times 9,8 times 8, that is the final potential energy, minus the initial potential energy, 5 times 9,8 times 0,6. It's equal to the kinetic energy gained by the block. So the only unknown is the height, the final height, and therefore the height can be calculated as 0.1699. This 2 versions is actually the same. The only thing that differs is the initial statement, the way it is stated. So again, 5 marks. Like in the first option, 1 mark for the formula, 3 marks for substitutions, and 1 mark for the final answer. Again, in this option, 1 mark for the correct formula, and then 3 marks for substitutions. In this instance, 2 marks before and 1 mark after mechanical energy after, 1 mark for the final answer. So in total, 5 marks. 1 formula, 3 substitutions, 1 final answer for both options. .4, give a reason why the ball is not reaching its original height, and we have already indicated it, because some of the mechanical energy of the steel ball is transferred to the block, and therefore it don't reach its initial height. Right? So some of the mechanical energy of the steel ball is transferred to the block. So the memo indicates some of the ball's mechanical energy is transferred to the block, 2 marks. There isn't part marking, it is 2 or 0. 2 or 0 for that. Then the next question, 4.5, states define or state the work energy theorem. The total or net work done on an object is equal. So this first part also, this equal is very important. The total net work done is equal. So 1 mark for that. Very important, that equal. And then the second mark is equal to the change in the object's kinetic energy. So there's actually a few crucial words. The total or net work done is equal, 1 mark, to the change in the object's kinetic energy. Part marking, if maybe something is omitted, maybe if the learner just states the work done on an object is equal to the change in the object's kinetic energy, then he forfeit the mark for the first part, but still can get the mark for the second part because it is still in the context. It's about the work done is equal. So it's not the net work done, that is wrong. So, but it will still get a mark for the second part because we see that it is still in the context of the work energy theorem. The second way of stating it is the work done by a net force is equal to the change in the object's kinetic energy. The last question is now about a part where after reaching point C, the block now moves up an inclined plane, and it's a rough inclined plane as indicated here, and this point E is 0.5 meters above point C. The question now asks, the block reaches point E with a speed of 2 meters per second. So 2 meters per second is given here. Use energy principles to calculate the work done by the frictional force. The work done by the frictional force. Not the frictional force itself, only the work done by the frictional force. So therefore, there's 2 ways of solving it. You can make use of the formula, the work energy theorem formula. Then you must realize there are 2 forces, a frictional force and the work done by frictional force, and then the work done by a gravitational force. Now, you don't have the angle of the incline, so the learner is forced to make use of this vertical displacement, because now the gravitational force is acting downwards. You must also make use of the displacement in the vertical direction. So therefore, the work done by the gravitational force is the mass times 9.8 times the vertical displacement, but the object is moving upwards, so the vertical displacement is upwards, and FG is working downwards, so it must be cos 180. Very important. Cos 180, or the learner must indicate -1. So 1 mark for the complete correct statement on the left hand side. WF equals plus the work done by the gravitational force equals to the change in kinetic energy. This is the final velocity, this is the initial velocity, both squared, and you get a value of -10.7 joule. So the work done by the frictional force while moving up the incline is -10. The next option is where the learner makes use of the formula for calculating the work done by the non-conservative force. The non-conservative force is the frictional force. It's equal to the change in the kinetic energy, 2 squared minus 4.95 squared, and the change in the potential energy. Therefore, it is the final height is 0.5 and the initial height was 0. It's very important to indicate this change in height. It's very important. Learners tend to leave out that 0. Please tell you they must make use of the zeros, because it is a change in potential energy. -10.7 joule. Mark allocation: 1 for a formula, 2 for substitutions, and 1 for the final answer in both options. 22 marks, quite a lot of marks for question 4. Question 5. Let us move on to question 5. And that is a question on the Doppler effect. And this is where the difference was in the values of this value of the constant speed with the Afrikaans paper. So I just alert the teachers marking Afrikaans scripts just to take that into account. It's a police car traveling down a road at a constant speed of 16 meters per second, and it emits sound waves from a siren. A man sitting on the side of the road with a detector registers sound waves are at a frequency of 440.74 Hz as the police car approaches. So for approaching, it is 440.74. That word, which is unfortunately not supposed to be there. Right, so approaches, the value is 440.74. Then after passing him and moving away at the same constant speed, the sound waves of frequencies 401.12 are registered. So very important. Away, 401.12 Hertz. First question, state the Doppler effect in words. Again, according to the exam guideline, very important, it is the change in the frequency of sound, because the sound source and the listener have different velocities relative to the medium of sound propagation. Part marking. The first mark is for the change in the frequency of sound, 1 mark. And then the second mark is because the sound source and the listener have different velocities relative to the medium of sound propagation. Again, the same principle. If a mistake is made in the first part, but it's still in context, for instance, if the learner writes, it is something about the frequency but not indicating the change of frequency, but the second part's autocorrect, you can give him a mark for the second part because it's still in context. But if this first part is not relating to something about frequency, it is not within the context, and then it is 0 out of 2. The other acceptable option is the option where the learner first get a mark for the change in the frequency or pitch. You will have seen pitch is also acceptable word, or pitch, because there's relative motion between the source and the observer. So this word then, relative motion. So different velocities, etc., or relative motion is the two important parts, phrases in the second part of the definition. So it's part marking, apply the principle of within the context. Right, if something is written in brackets, it is actually part of the complete definition, but we give the benefit for learners. If they omit it, we don't penalize them. So if part of the statement or definition is put in brackets, it's actually part of the definition, but we don't penalize the learners if they don't use that specific word. Actually, this or pitch are not supposed to be in brackets, but it's maybe more can be actually be indicated as a slash, change in frequency or pitch. That is the definition of the Doppler effect. Next question is about calculating the speed. Sorry, all right. It's about calculating the speed of the sound waves. In the information given, you will see there's a frequency when approaching, there's a frequency when moving away. But the speed of the sound waves is not given. And secondly, the frequency of the sound waves from the siren is not given. So there are two unknowns. So therefore, immediately, because there are two unknowns, the learner must realize that he can't do it with one equation. Therefore, the simultaneous equations, 1 mark for the formula as per data sheet, 1 mark. The second mark is firstly for the frequency that the listener detected when moving towards him. So this value of 440 must relate to V minus 16. 1 mark for each. The second equation for the sound, the siren, the police car moving away, the frequency detected when moving away must relate to V plus 16. So 1 mark for this frequency, 1 mark for the V plus 16. Actually, it is for the complete part. This whole statement of V divided by V minus 16. That is for which the second tick is. So you have now two equations with two unknowns. So therefore you must solve it simultaneously, and when you do that you will get an answer of 339.97 meters per second. Now for the Afrikaans learners, this value will be 10.6, minus 10.6 and plus 10.6, and therefore you will get an answer of 225.24 meters per second. Not a very realistic answer, but still that is the answer. So please award marks for this answer in the Afrikaans scripts. 1 mark for the correct formula for Doppler, and then 4 marks for substitutions. 2 marks for each of the equations, 4 marks, and then 1 mark for the final answer, therefore a total of 6 marks. 5.22 then asks what is now the frequency of the sound emitted by the source, the siren. Now you can use either equation 1 or equation 2 to calculate Fs. And this is the two options, so either 440 and minus 16 or 401 and plus 16. Any one of the two options are acceptable, and now there's no mark on a formula. It's only one mark for a complete correct substitution process and one mark for the final answer. 2 marks only. Yeah, the learners will not write if L is actually, you can repeat that 440 and this 401 again here. 1 mark for a complete substitution, 1 mark for the final answer for 19,99 Hertz. Then for the Afrikaans learners using the Afrikaans paper, this answer will now be 409,43 Hertz, because on their paper it will be minus 10,6 or plus 10,6. So remember 409,43 for the learners who have completed the Afrikaans paper. That is Doppler. I think quite fair question on the Doppler effect. Moving on to question 6 on electrostatic forces. It is a scenario about 2 spheres on isolated stands, and each carrying a certain charge, R of a charge of positive 8 times 10 to the power minus 6, and S a charge of minus 4 times 10 to the power minus 6. Now R and S are brought into contact for a while and then separated by a small distance. So calculate the net charge on each sphere. The learner must make use of the principle of conservation of charge, and so therefore you will know, because it's identical spheres, the charge on each sphere will be the same. So it's a total charge on both spheres divided by 2, and therefore plus 8 minus 4 divided by 2 gives you 2 times 10 to the power minus 6 Coulomb. 2 marks. No mark, unfortunately, for the equation. 1 mark for substitution and 1 mark for the answer. With a unit, remember, if a unit is omitted, it is minus 1. Unit omitted, minus 1. That's a principle throughout the paper, and it is once per question. Remember, once per question for omitting a unit or for a wrong unit. Now, after R and S has been in contact and separated, and why it is highlighted, because the learner must now use that value calculated in 6.1, that value of 2 times 10 to the power minus 6. Right, then a third sphere T of 1,5 times 10 to the power minus 6 is placed as shown in the diagram. So it's placed 0,1 meters from R and 0,2 meters from S. What is important now is that all 3 spheres are positively charged. All 3 spheres are positively charged. And now the next question you will see, the learner must now draw a force diagram of the forces acting on sphere T. Right, positive repels positive. So sphere R is exerting a force away to the right. So the force of R on T is to the right. But sphere S is also repelling sphere T, so sphere S exerts a force to the left. So S on T is to the left, therefore the The correct force diagram will be a force to the right and a force to the left. 1 mark for indicating the two forces in opposite directions. So it is an arrowhead indicating a force to the left and the right. 1 mark. And then the second mark is for indicating labels. So if the learner only draws this force diagram, it is 1 mark. If he indicates the two labels, it is 2 marks. So 1 out of 2 if there is no labels. Now the next question now asks, what is the net electrostatic force exerted on sphere T? So now we must calculate the force exerted by R on T, the force exerted by S on T, and then calculate the net force. So let's look at the calculation. Firstly, 1 mark for showing Coulomb's law, the formula for Coulomb's law. Then 1 mark for substituting the values for the force exerted by S on T. So very important, the distance between the two spheres is 0,2 squared. So 1 mark for that substitution, no mark for the answer. 1 mark for substituting the values for the force that R exerts on T. So now it's important that the distance between the two spheres is 0,1, and to remember the square part. Learners often forget to square these values. No mark for the answer. 1 mark now for subtracting the two values or adding the two vectors. One must has a positive value, for instance to the right, and one must have a negative value indicating to the left, and therefore your answer is a positive answer, and according to that the direction of the net force is to the right or towards S. So 1 mark for subtracting the two values, indicating that it is in different directions. 1 mark for the answer, and 1 mark for indicating the direction. So 1 formula for a formula, 1, 2 for substitutions, 1 mark for subtracting these values, 1 mark for the final answer, and 1 mark for the direction. In this option 2, then please remove these 2 ticks. There's only 1 tick if the learner has instead of doing this has made use of this option here. So it's only 1 tick. So this option just replace that part, but the rest must be the same, please. It's a little bit unclear on that. That is now 6.3, the first and the second option, and now also there's a third option. And the third option is where the learner first calculate the electric field that acts on T due to R. So the distance of 0,1 is used. You will see the value of Q is the same in both instances, but the distance between the two spheres differs. So the electric field of R is then calculated as 1,8 times 10 to the power 6, and then the electric field due to S that acts on sphere T is then 4,5. Then you will get the net electric field at point T where sphere T is, and the electric fields acting on the two spheres again is in different directions. the same. If I maybe just can indicate here also, the electric field is of R is to the right. So the electric field due to R is to the right, and the electric field due to S at this point where T is situated is to the left. So you must subtract the two electric fields from each other, and therefore this is why this is 1,8 minus 4,5, and then you make use of this equation for which is derived from the definition of electric field to get to the net force. Let us recap. 1 mark for the formula, and in this instance for the formula of either E equals kq over r squared. Sorry, there is errata here. There's errata there. Or for the formula F net equals E net times Q. So for either of these formulas, 1 mark. So it is still 1 mark for the formula. 1 mark for the substitution of calculated electric field due to R. 1 mark for calculating the electric field due to S. 1 mark for subtracting the two values. And then 1 mark for calculating for the answer of F net, and 1 mark for the direction. Again, this part can be substituted by this option here. So that is why it's actually not a different option. It's just another way for calculating the electric field caused by S, sphere S. Okay, I hope this is clear to you. Let us move to question 7 on electric fields. And again, you have two charged spheres, M and N. The charge on sphere M is given to you as +6, etc. And then the charge on sphere N, the learner must calculate by using information that N carries 5 times 10 to the power 6 excess electrons. Then there's a point P that is 0,1 meters to the right of sphere N. Calculate the charge on sphere N. So now the learner must calculate what is the charge on sphere N due to this number of electrons. By making use of this formula, you substitute the number of electrons, you substitute the charge, the value of the charge of 1 electron, the unit value of the unit charge, and then you calculate the total charge on sphere N as -8 times 10 to the power 13 coulombs. So 1 mark for the formula, again 1 mark for the correct substitution of both the number of electrons and the charge of an electron, and 1 mark for the final answer. So the learners must really be accurate on their substitutions, because the way marks are allocated, the learner, by making a mistake on one of his substitutions, will at the end only get 1 out of 3 if his formula is correct. So it's very important that they must really be accurate, because there's not 4 marks allocated on such a question. You will see also in the final exam they won't award 4 marks for this question. The paper doesn't allow it. So therefore, be sure that you are accurate on the substitutions. Then the next question is to define what an electric field at a point is, right? If you can go to the question, calculate, define the electric field at a point. Right. Actually, this is tends to be a 2 or 0. Let me try to explain how you can mark this. It is the force experienced per unit positive charge at a point. If the learner omits any of the key words, you will lose a mark. Let me explain. If the learner writes the force experienced per, very important, per unit charge, you will get 1 out of 2 because the very crucial word of unit positive charge is omitted. So 1 out of 2. If the learner writes down the force experienced per positive charge, then he again will lose 1 mark because he omits the unit charge. If a learner just write down the force experienced by a charge, force experienced by a charge, it is 0 out of 2 because both crucial terms, the unit and the positive charge, is omitted. So a force experienced by a charge is 0 out of 2 because the very important part of the per unit positive charge is omitted. So therefore, it looking at this, it actually relates to a 0 or 2. But you can have part marking working with these 2 crucial terms. So that is 1 mark deducted for each key word omitted. Looking at 7.3, draw the electric field pattern due to the charge spheres M and N. Right, it is opposite charge spheres. M is positive and N is negative. Therefore, this is the shape that the learner must indicate. And I must immediately refer to the fact that because there's a slight difference in the value of the positive and negative charge, you will, in the calculations, you will have realized that the charge given here is plus 6 times 10 to the minus 12, and the charge calculated is minus x to the power of 13 coulombs. There's a difference in the value of the 2 charges. Let me just see here. Here's a mistake on this. Let me just see. Okay, I'll maybe refer to it back later. Right, so actually, technically, there can be a difference in the density of the field lines of the 2 spheres because the value of the 2 charges differs. But we are not going to, please, actually it is, we haven't indicated a difference in density of field lines. So accept the field pattern if the density of both field lines are the same. So it is 1 mark for the correct direction away from the positive charge and towards the negative charge. The shape, the correct shape indicated on the diagram, and then the field line starting from the sphere and not crossing. So it must touch the sphere and nowhere field lines must cross. So if that is not touching the sphere or crossing, minus 1, it's the direction is wrong but the shape is correct, then you will get 1 for the shape, but -1 for direction. And if the field line is not crossing, he can get 2 out of 3. So you mark according to this marking criteria given here: shape, direction, and the third mark for touching and field lines not crossing. Right. Moving on to the next question. Calculate the magnitude of the net electric field at point P. Calculate the magnitude of the net electric field at point P. So the electric field at point P due to M is in the direction to the right. Electric field due to M. The electric field through point P due to N must be towards N, therefore to the left. Let me just repeat here. The electric field through point P due to M, because M is positive, is away from M, is to the right. The electric field due to N through point P is to the left, therefore towards the negative charged sphere. So therefore at the end you must deduct the 2 electric fields through point P to get the net electric field. Right, let's just look at the memo. 1 mark for using the correct formula. 1 mark for substituting the correct values. Remember, the 6 times 10 to the power minus 12 must relate to the 0.25 squared. And the 8 times 10 to the power minus 13 must relate to the 0.1 times squared. So 1 mark for the substitution of the electric field due to M, 1 mark for all the correct substitutions to calculate the electric field due to N, no marks for the final answers. The 4th mark is for subtracting the 2 values, and the 5th mark is for the final answer. There's no direction because the magnitude of the net electric field is asked. So 1 for the formula, 2 marks for substitution of calculating the electric field due to the 2 spheres, 1 mark for subtracting the 2 values, 1 mark for the final answer. I just want to make a correction at the previous question 7.1. That must be minus 13. Sorry for that. Right. This is then question 7 on electric fields. Then we are moving on to question 8. The question on circuits, electric circuits. And the question states as follows. In the circuit below, the battery can supply a maximum of 12 joules of energy per 1 coulomb of charge, or you can just have stated per coulomb of charge. The resistance of the connecting wire is negligible. The internal resistance of each cell, highlighted, caps, in the battery is 0.2 ohm. It's a combination of a parallel part in the circuit and this resistor in series, the battery with internal resistance. First question, state Ohm's law in words. Part marking again. First part, the potential difference is directly proportional to the current, 1 mark, provided that the temperature is constant. Potential difference directly proportional to current, 1 mark. Condition, 1 mark. That is Ohm's law. The second question is, give the phrase for the underlined words. So the maximum energy of 12 joules per coulomb charge. What does this refer to about the battery? So the fact that it's the maximum energy per coulomb charge, it must therefore relate to the EMF of the battery. The next question. S is now closed and the voltmeter now measures 6.75 volt. 6.75 volt. And now they ask to calculate the current in the battery. A very easy question. It's because you have the potential difference across this series resistance. You have the value of resistance. So by making use of Ohm's law, you can just calculate R equals V over I. The resistance is 9 ohm. The potential difference is 6.75, and the current through that series circuit, series resistor, and therefore the total current in the circuit is equal to 0.75. 1 mark formula, 1 mark for correct substitutions, and 1 mark for the final answer. Then the more difficult question, calculate the resistance of resistor R. Now you will see R is part of a parallel part of the circuit. You have information about the potential difference across the 9 ohm resistor. You have the internal resistance of the battery, and you have information about the total current. So certainly there are a few ways of solving this. Solving for R. So you must get the value of the parallel resistance of these two resistors, and then you will be able to solve R. So the different ways of solving a problem is getting to calculate the total parallel resistance. So let us look at the two ways of doing it. The first way of doing it is knowing that the EMF is divided into the external potential difference and the internal potential difference, and then realizing that the external potential difference is split between Vs, the series part, and the parallel part. And then by further elaborating, by making use of Ohm's law, V equals I times R, you can realize that the total resistance is due to internal resistance, the series resistor, and the parallel combination of resistors. So therefore, the 12 volt is known, given EMF. 0.75 is positive marking from the previous question. 0.4, and now we will see there is a specific tick on the 0.4 because the information given about the internal resistance, that each cell has internal resistance of 0.2 ohm, and in the diagram it's clearly indicated that your battery consists of 2 cells. So because it's in series, the total internal resistance is not 0.2 but 0.4. So you will see there's one tick on the 0.4 specifically. Then plus the series resistance and the parallel RP, 9 plus the unknown parallel resistance. So therefore you can calculate it R parallel. So for the first part, getting to calculate R parallel, there's 1 mark for a formula, and actually this part is actually a version of Ohm's law. So any way of stating one of these formulas, 1 mark. Then for substitution of the EMF, for the substitution of the 0,4, and then if the whole statement is correctly substituted on the right hand side, there's an extra mark for the right hand side totally correct. There's no mark on the final answer. 1 mark for the formula, 1, 2, 3 marks for substitutions, 4 marks. The second option, if you would like it, for the first part is the way where you calculate first V lost, then if we have V lost, you can calculate V parallel by knowing that the total EMF is divided between the battery 0,3 volt, the series resistor of 9, let me just see here, of 9 volt. Okay, this don't seem correct. I'll just refer to it back later. I think this cannot be correct. I think this must be the value calculated. Let me just see the value given. Let's quickly go back to the question paper. The voltmeter measures 6,75. So actually that value must be 6,75. So let's make that correction there. 6,75, and then you get a value of 4,95 volt, the parallel voltage, and then by means of Ohm's law you can calculate the parallel resistance. Now this is a very more difficult way to get to RP, but just recap on the marks. There's 1 mark on a formula, like in the previous option. There's 1 mark for the substitution of the 0,4. Then there's 1 mark on the 12 volt, and there's 1 mark on the total correct substitution part on this right hand side. So it stays constant with this previous option. 1 mark for a formula, 1 mark for 0,5, 1 mark for 12 volt, and 1 mark for this complete right hand side. So it stays 4 marks, like in this option. And then for no marks for this last part. You see no marks there. Then moving to the final step, calculation step, by making use of the formula for parallel resistors, you can then calculate the value of R, because the parallel resistance is 1 over 6,6, and again it's positive marking from the previous step, plus 1 over R plus 1 over 10, and therefore you can calculate the resistance of R as 19,41. This 10 is given, you will see on the diagram. This right. To recap, 4 marks for the first part, getting to R parallel as 6,6. Remember that 0,75 is positive marking from 831. Remember then, if he uses that value from 831, he can get full marks, but because it's positive marking from a previous question, then you must work with the answers of the learner right through. So if using his wrong value from 831, he can get full marks if everything else is correct. The second thing, if he has calculated RP, he has a correct current, but he have made a mistake in his calculations, and that value differs It's not 6,6, but is substituted there. Again, you can give him 1 mark on this substitution step. Remember, this 1 mark is for the complete substitution step. Okay? 1 mark is for the complete substitution step, and then 1 mark for the final answer. Right, I hope that gives clarity on marking that question. Let's move on to question 8.4. It's very common to connect many appliances to a multiplug, which results in overheating. Modern multiplugs have a cutoff switch built to avoid this overheating. Use the knowledge of parallel circuits and explain why this cutoff switch is important. And I'm certain that all learners have seen a cutoff switch used in some of the more expensive multiplugs. Every multiplug don't have that cutoff switch, but like I said, the more expensive ones have one. Right. What happens when more appliances are connected to a multiplug? The important part, the total resistance decreases. If more appliances are connected to the multiplug, because they are connected in parallel, the learner must realize that they are connected in parallel, the total resistance will decrease, causing the main current drawn to the multiplug to increase. And you will see it's in brackets, so they don't have to stay drawn to the multiplug. So the main current to the multiplug increases 1 mark. And due to that, the heating effect increases, because looking at all the formulas for W, for instance, W equals I square RT, the learner must realize the heating effect will increase and overheating will be caused. Or the learner can state, again, the number of appliances, if it increases, the total resistance decreases 1 mark. Therefore, the current drawn will increase 1 mark. And instead of stating that the heating effect increases, he can state that the power dissipated increases, also causing overheating. So he can also refer to the power dissipated increases for the 3rd mark. Right, a practical question. That is question 8. I think some challenging question, but at the end I think a fair question. Question 9. Moving on to question 9. And it is the question about electrodynamics and alternating current. Right. Simplified AC generator is shown in the diagram below. The main components are labeled A, B, C, D. There's actually nothing asked about these, so we could have omitted that label. Name the principle on which the generator operates. So a generator operates only on one principle, and the principle is a principle of electromagnetic induction, and that is the only correct answer. 9.21, write down the name of the component labeled. 9.2a, and A must be slip rings, and only slip rings, not split rings, but slip rings. And B is brushes. So slip rings A and brushes or carbon brushes B. 9.3. Will the induced EMF be a maximum or a minimum as component C is in the position shown above? Here is component C, and you will see it is in the horizontal position between the two magnets. Now you must realize that is the position of the maximum change in the magnetic flux, and therefore, if that is the case, the maximum EMF will be generated moving through this horizontal position. So it is a maximum, the maximum position of maximum EMF induced. Right. 9.4, it's now moving away actually from this generator indicated above. An AC supply is connected to a light bulb. The light bulb lights up with the same brightness as it does when connected to a 15 volt battery. It's an AC supply, but it lights up with the same brightness, so the same power is generated as when it's connected to a 15 volt battery. So battery produces DC current, direct current. So now write down the RMS voltage of the AC supply. So you must realize that this is actually the definition, related to the definition of what RMS voltage is. So if it lights up, if it dissipates the same power when connected to a 15 volt DC battery, that is actually the value of the RMS voltage of the AC supply. Therefore, the answer must be 15 volt. 942 is the power rating of the bulb is 60 watt. Calculate the peak current through the light bulb. So you have a light bulb and it's indicated 60 watt, you buy it. Now the question asks, what is the peak current through the bulb? Right, you must get Imax. What you have to your disposal is P average, that's a rating of the bulb. You have realized in the previous question that the RMS value of this AC generator, the voltage is 15, VRMS is 15, so you can calculate the IRMS of the AC source. So therefore you can calculate it IRMS as 4 amperes. Then you can make use of this formula to calculate Imax. IRMS 4 amperes divided by square root 2, so you get the answer of Imax as 5.66 amperes. Let's look at the mark allocation. Here are actually 2 marks for formulas. The first mark for this formula, using the average power dissipated, calculating the average power dissipated. The second mark on the formula for IRMS. 2 marks for formulas. Then 1 mark for substituting into the first formula. The second substitution mark is for the second formula, substituting into the 4 amperes into the second formula, and then 1 for the final answer. So 1, 2 for formulas, 1, 2 for substitutions, 1 for a final answer, 5 marks. Option 2. Now this learner makes use of 3 steps, 3 formulas, and therefore, because in fact that the first part isn't necessary, because it isn't the shortest way of calculating solving this problem, the learner calculates the resistance of the bulb as 3.75 by means of this formula for power. But getting to the 3.75, no marks are awarded. Then getting to the second step for calculating IRMS, like in the previous option, using Ohm's law, and 1 mark for stating Ohm's law, 1 mark for correct substitutions, no mark for the final answer, like in the previous option. Then using that answer in the next calculation, 4 amperes, so 1 mark for the substitution and 1 mark for this third formula, and then 1 mark for the final answer. Let us remind you on the principle that you deduct once for omission of subscripts per question. Once for omission of subscripts. In the case of Ohm's law, if the learner uses Ohm's law, he or she is not forced to use subscripts when using Ohm's law, but all the other formulas for electromagnetic induction, for calculating problems concerning AC problems, the learner must show subscripts except when using Ohm's law, and you deduct only once for a subscript per question 9. Right, let us recap. 2 marks for formulas, 2 marks of substitutions into each formula, 1 mark for a final answer. The same here, 2 marks for formulas, 2 marks of substitutions, 1 mark for a final answer. Let's move on to the next question. It is now 9.5, and the question asks the following. An AC generator can be converted into a DC generator. Name the component needed to effect the above conversion. Now you know, if you have a AC generator, the important component is slip rings. If you want to convert it into a DC generator, you must replace the slip rings by split rings, a split ring commutator. So the answer is therefore that you must replace it by making use of a split ring. 1 mark for that. The next question, sketch the induced EMF versus time graph for a DC generator for 1 complete cycle. Sketch an induced EMF versus time for a DC generator for 1 complete rotation of component C. Right, the possibilities are as follows. Firstly, you can take both options. Take the peak voltage as positive or negative, doesn't matter. The correct way, looking at the diagram, the more correct way is starting at the maximum. But it really, the answer don't force you to relate to the diagram. But anyway, the first option is starting at the maximum and then complete 1 complete cycle. The other way is starting at the minimum and then complete 1 complete cycle. Right, this is the same. Starting at the maximum, 1 complete cycle. Starting at the minimum, 1 complete cycle. The way you mark this is 1 mark for a correct shape. And you will see the shape is correct. It's not a AC generator, so it doesn't have a sine curve. So for the shape, 1 mark, and then for 1 complete cycle, 1 complete cycle, 1 complete cycle, 1 mark. 1 mark for shape, 1 mark for 1 complete cycle. So for instance, if the learner has started off from there and ending up there, it's a correct shape, but it's not 1 complete cycle, so you will get 1 out of 2. Right. If the shape is actually wrong, if he uses a sine curve, the curve of a sine graph, then it is for an AC generator, then it's actually 0, because then it isn't a correct shape. So if the shape actually isn't correct, then he forfeit the mark also for the next mark, then it will be 0 out of 2. So it must be a correct shape to start off awarding marks. Correct shape 1, and then secondly, if there is a correct one complete cycle, the second mark. 13 marks for question 9. Moving on to the last question, the question on the photoelectric effect. Right, the question states the following. Right, the question states the following. In an experiment, a light of different frequencies is shone onto 2 photocells, one with cesium cathode and the other one with sodium cathode. The sketch graph of the frequencies versus kinetic energy of the emitted electrons are shown below. Right, cesium cathode, sodium cathode, kinetic energy versus frequency. Define the term threshold frequency or cutoff frequency. Like in the exam guideline, 2 important parts. It's the minimum, very important, frequency. If the learner relates to energy, it is 0 out of 2. It's not in the context. So the first important part, the minimum important, frequency important. If he states minimum energy, 0 out of 2. The second part that's important, needed to eject photoelectrons from a surface or from the metal surface. Minimum frequency needed to eject photoelectrons from a metal surface. If he just states from the surface, it's also correct. Therefore, we have put the metal in brackets. Energy related, 0 out of 2. So that is 2 marks for the definition. The next question asks, which photocell will, for the same frequency of light, emit photoelectrons of higher kinetic energy? Choose from cesium or sodium. So clearly, you can see for a certain frequency, let us take this frequency. For a certain frequency, the kinetic energy of cesium has a certain value, but for sodium it is still 0. So certainly the kinetic energy of the photoelectrons of cesium is of higher value. So the answer is the cesium cathode. 10.3, name the energy value as shown as A. So this energy indicated here, that is the energy needed to remove the electron from the surface of the metal or the material before it is released with a certain kinetic energy. So this energy value relates therefore to the work function. Relates to the work function. 10.4, write down the name of the quantity represented by the gradient of the graph. There was a question relating to this graph a few years ago, and if you use this as equation, if you use the equation of a straight line and using the x and y values, you will see that this actually relates to the gradient of the graph relates to Planck's constant h. So the gradient of the graph relates to Planck's constant h. Then The next part, 10.5 and 10.6, the last two questions of the paper. For a certain frequency of light, the maximum kinetic energy of a photoelectron from a sodium cathode is 2,03 times 10 to the power minus 19. So, very important, the photoelectron of a sodium cathode. So, we must immediately now relate to the sodium cathode. And now what's very important, now the learner must realize that this is the threshold frequency. This is the threshold frequency for sodium. Right. So if we use the formula that he's supposed to use, and then there's 1 mark for the formula. The question now asks 10.5, the wavelength. Calculate the wavelength of the light used. The wavelength of the light used. Right. Getting to the formula. This part is the energy of the photon. Why we haven't used, for instance, E equals HF, because they specifically ask the wavelength. So, for this part, Planck's constant times the speed of light divided by the wavelength of the light used is equal to, so 1 mark for this substitution, is equal to the work function for sodium. And the work function for sodium can be calculated by using the threshold frequency for sodium. So the learner must realize this value is the threshold frequency, so very important, making use of that 5,31 times 10 to the power 14. So 1 mark for this substitution, and then 1 mark for the value given in the question, the value of the kinetic energy of a photoelectron emitted from the sodium cathode. And then 1 mark for the final answer. Right, 1 mark for formula, 1 mark for substituting the values for the energy of the photon, 1 mark for calculating and substituting the values for calculating the work function, and this is maybe the difficult one and the important one, and 1 mark for kinetic energy, 1 mark for answer, 5 marks for this question. You must maybe have a look on learners 10 to calculate the energy of the photon separately and maybe the work function separately, and then maybe add it together. So you must just give marks accordingly. The last question, and just finishing in time, is the question 10.6. And now the question asks, what influence will the following changes in the incident light have on the maximum kinetic energy of the photoelectrons emitted? What will they have on the maximum kinetic energy of the photoelectrons emitted? Choose from increase, decrease, stays the same. Right. What will happen if you increase the wavelength of the light? If you increase the wavelength of the light. Now, looking at this formula for the energy of a photon, the energy of the photon is inversely proportional to the wavelength. So if you increase the wavelength, the energy of the photon will decreases. So therefore the answer, the energy of the photon will decreases. Very important, the energy of the photon, because that is a very important part in the description. The energy of the question is what will happen with the kinetic energy of the photoelectron. So therefore the photoelectron's energy will decreases. Why? Because the energy of the photon will decreases. So in the explanation why, the learner must refer to the photon. the energy of the photon. What happens with the energy of the photon? Right, so 2 marks, 1 for the answer decrease, and 1 mark for the explanation. And the last question, what influence will it have on the kinetic energy of the photoelectron emitted if there's an increase in the intensity of light? And now we know that the intensity of light only increases the number of photons released per second. So it has nothing to do with the energy of the photons. Therefore, it means that the kinetic energy of the photoelectrons will stay the same. Why? Because intensity has no influence on the energy of the photons. 1 mark for the answer, 1 mark for the explanation. Right, I hope this will give clarity on the memo. Unfortunately, we're not maybe on a live broadcast, so I think the questions will be answered maybe at the later. Other questions may be answered at the later stage. Thank you very much for staying with me. All of the best for the last month or 2 with your grade 12s. Thank you very much.